We're busy with redox reactions. And we're looking at the example where sodium will react with chlorine. And we find these, some reactions are easy to figure out yourself, but some of them we need the table of reduction potentials. We are still going to get to the point where we're going to use the reduction potential. So don't worry about that. We'll still do it. When we look at the table, sodium is at the top right-hand side of double arrows, and all the reactions are written as reversible reactions. And we've got the sodium ion plus an electron, double arrow sodium. And at the bottom, close to the bottom of the table, we have chlorine taking electrons, double arrow, 2 chloride ions. So, because sodium causes the reduction of chlorine, it's called the reducing agent. It's also very quick to use the table of reduction potentials to identify reducing agents, but because they'll be on the right-hand side of the double arrows. All the chemical substances on the right-hand side of the double arrows will be reducing agents. Then we see that chlorine is on the left-hand side of the arrows. What does it cause? Chlorine causes oxidation. So what is it called? So because it's causing oxidation, it is called the oxidizing agent. Now I'm going to ask another question. Will this reaction happen spontaneously? Will the reaction between sodium and chlorine be spontaneous?
Yes, it's spontaneous.
That's the big question. Okay. We could look at one of two sides. We could look at the reduction side, or we could the reducing agent side, or we could look at the oxidizing agent side. I'm used to looking at the reducing agent side. Okay? What chemicals are we mixing? We're mixing sodium and we're mixing chlorine. What is sodium? It's a metal, but it's a reducing agent. In the whole process, what is another reducing agent? If we look at all the chemicals involved here, what is another reducing agent? Cl negative is also a reducing agent. Okay. Which one is the stronger reducing agent? Sodium is the stronger reducing agent. It is stronger than the other reducing agent that will be part of the whole reaction. Because sodium is a stronger reducing agent than the chloride ion, the reaction will take place spontaneously. Okay? So, because sodium is a stronger reducing agent than the chloride ion, the reaction will take place. The reaction between sodium and chlorine will be spontaneous. Sodium is a stronger reducing agent than the chloride ion. Therefore, sodium will reduce chlorine spontaneously. If I have something that I don't know how it will pan out, I can use the table of reduction potentials to see which one is the stronger reducing agent, which one is the weaker one. The stronger reducing agent will cause the reaction to happen spontaneously. Yes?
Let's say now we use the Cl negative as the reducing agent. Do we then say that the Na plus is the oxidizing agent?
No, Na plus is the oxidizing agent. This is a reducing agent. That's an oxidizing agent. I'm going to go the oxidizing agent now. I'll look at it through the oxidizing agent path. Can I take away the reducing agent scribbles? These ones. I want to take away these ones. Okay. Okay, ready? So chlorine is an oxidizing agent, and the other oxidizing agent in this whole mixture of chemicals is sodium ion. So this is also an oxidizing agent. So in our mixture of chemicals, we'll have sodium, chlorine, sodium ions and chloride ions. And we need to be able to work from the oxidizing agent side as well. Okay? So which one is the stronger oxidizing agent? Cl is the stronger oxidizing agent. It is stronger than the sodium ion, which is an oxidizing agent. So when I mix chlorine and sodium, will the reaction take place spontaneously? Yes, because chlorine is a stronger oxidizing agent than the sodium ions. It will oxidize sodium to sodium ions spontaneously. So, chlorine is a stronger oxidizing oxidizing agent than sodium ions, therefore it will oxidize sodium to sodium plus spontaneously. Why are you looking through one eye? Okay. Where are your glasses?
You see, I said the same thing. And then my glasses cost 4,000 rand next time because it was a battery. So
okay, so we're going to compare copper to and chlorine. Yeah, I'm just referring to it won't be the copper 1, so it's not copper 1 plus. You'll see on the table of reduction potentials that there would be more than one copper reaction. So find a reaction where copper changes to copper 2. So on which side? Copper 2 plus. So which one is the top one, the copper or the chlorine one? I think the metals are higher than most of the non-metals. So copper. Now is it going copper 2 plus 2 electrons, double arrow? No, I want the 2 electrons one going to copper. I want that one. You got it? You got it? You got it? Look for it. It's copper with a valency 2, so it's copper 2 plus. I want a reaction. I want you to find the reaction where copper 2 plus gains 2 electrons to go to copper. And I want you to find again the chlorine reaction where chlorine gains 2 electrons to make 2 chlorines. That's the forward reaction. Okay, so this is the bottom one, that's the top one. The higher up one and the lower down one. Okay, so let's try and use our way. We're going to mix a copper 2 solution and a chloride solution. So we're going to start off with the copper 2 and the chloride. So we've got copper 2 plus ions in the solution. This is what we start off with copper 2 plus and chloride. Will this reaction be spontaneous is my question. Will this reaction be spontaneous? I'm going to, you look at either the oxidizing agents or the reducing agents. What do you want to look at? Okay, so this is an oxidizing agent, and this is an oxidizing agent. Okay, which one is the stronger oxidizing agent? This is the stronger. Look at the arrow on your table. The arrow pointing down on the left hand side means that this says increasing oxidizing ability. It says increasing, whoops, oxidizing. Am I right?
Yes.
Ability. No. And on this side, it says increasing, reducing ability.
Oh, strength. Okay.
What did they say? Increasing?
In strength.
Reducing ability. No, we're looking in the text.
On the table, in the textbook. Okay, but it still says the same thing. Okay, so if you want to use the oxidizing agents, this chlorine is the stronger one.
Sorry, so if we use the reducing agents, that means we can follow the increase in reducing ability.
Yes.
Okay.
But I'll do that one for you as well, because lately they've been forcing you to answer it using oxidizing ability or forcing you to do reducing ability. But it doesn't matter. The song you sing is the same thing. Yes.
Oh no, I was going to say, in the first example that you did, you swapped, you did redox and oxidation. Like,
I don't want to do it now. I want you to see how to answer the question from the table. So when you have a solution of copper chloride, you've got copper ions and you've got chloride ions. So why am I putting it there on the side? We've got this and we've got that. That's what we start off with. So my question is, will this reaction be spontaneous? Now you see, the oxidizing agent that you've got is the weaker oxidizing agent. This is the weaker. You've got the weaker oxidizing agent. Will it oxidize the chloride to chlorine? No. The weaker oxidizing agent, copper 2+, because copper 2+ is a weaker oxidizing agent, than the chlorine, it will not oxidize the chloride to chlorine spontaneously. See, the chloride here is actually a reducing agent. Because you mix this weak oxidizing agent with that reducing agent, the reaction can't happen.
so if it was the other way around, let's say it was strong.
No, then I have to go to another example, like the sodium chloride example. I know what you want me to do. You want me to write the half reactions down. That's what you want me to do.
You can if you want to.
I'm going to now. Okay. Can I make the green here disappear?
Yes.
Okay. I just wanted you to see what we start off with in a different way.
Wait, ma'am, so these substances are already in solution.
The copper chloride is in solution, yes.
It's
Will the reaction happen by itself? Answer is no.
They already to separate.
Yes, will they separate? Will copper 2 plus turn to copper spontaneously?
Yes.
No, because copper 2 plus is a weaker reducing agent. You see, the reaction that's going to take place, is the copper 2 plus 2 electrons will be going to copper, and the chloride will go to chlorine. This is the chemical reaction that will take place. But will it be spontaneous? The reason why it's not spontaneous is copper 2 plus is a weaker oxidizing agent than chlorine. So the copper 2 plus cannot oxidize the chloride to chlorine.
Okay, ma'am. Basically, this is okay. For example, a question. They can give us two substances. For example, we were working with copper and chlorine right now. So, ma'am, and the next step we're going to look at where are they located at? Right, ma'am? That which one is above and which one is below. And then that's how we write it, right? And then, ma'am, when we're done writing it down, we choose if we are using the oxidizing or the reducing agent. And then, ma'am, afterwards, we take the reactant of the first equation, the equation that's at the top.
What you start off with.
Yes,
so we
ma'am.
would have copper 2 plus to start off
Yes.
with, and chloride to start off
And
with.
we mix them together.
They,
And to see if
if it's spontaneous, you have to compare the oxidizing agents or compare the reducing agents.
Oh, okay. And we can see.
Okay, so this would be your gaining electrons reaction. So this is the reduction half reaction, and this is the oxidation half reaction. Will the reaction be spontaneous? The answer is no, because copper 2 plus is a weaker oxidizing agent than chlorine. Copper 2 plus cannot oxidize chloride ions spontaneously.
Okay, now you should know you oxidize which one are we going to use, oxidizing agent or the reducing agent. Let's say we're using the reducing agent, right, ma'am?
Let's do it.
Okay, let's do it.
Let's do it. You see, you are a little bit out of the picture now, but I don't know if you can remember the electrolysis of copper chloride solution. Can you remember the reaction? We did it in grade 8 already. The electrolysis of copper chloride solution. Can you remember it? You had this blue container of blue copper chloride solution. We put electrodes in, and then we noticed on the one electrode copper formed, and on the other electrode we could see the bubbles and smell the chlorine. But I didn't want to start there. I wanted you to learn a new way to identify whether a reaction will be spontaneous or not, because you have to be able to do it. And I wanted to use something you're familiar with. Now you know that we used electricity to force that reaction. It's a redox reaction, but it's not a spontaneous redox reaction.
Oh, because electricity is added.
Yeah,
Yes.
additional energy actually added into the
Yes.
system.
Yes. Okay? Let's use the reducing agent things. I just want to take this away. So we're going to look at the reducing agents now and compare their strengths To explain the same thing, we have to be able to do reducing agent things. Look at it from the reducing agent perspective. So, we know that we've got chloride ions to start off with, and we've got copper ions to start off with. Shouldn't have done that. Now we're doing the reducing agent ones.
Are we picking?
Copper is a reducing agent, right? This is a reducing agent, the copper, and chloride ions is our another reducing agent. Which one is the stronger one? The copper is the stronger one, but it's not present. You see, so we look at the weaker, a weaker reducing agent will not reduce the copper ions to copper spontaneously.
What do you mean it's not existent?
This reaction, the weaker reducing agent, cannot cause the copper 2 plus to become copper spontaneously. This reaction, where the chloride ions will be oxidized to chlorine and the copper ions will be reduced to copper, will not take place spontaneously. Because chloride ions are weaker reducing agents than copper. Chloride cannot reduce copper 2 plus to copper spontaneously. The reaction is a non-spontaneous redox reaction.
Going back to you saying, okay, basically we're working in reverse compared to the last.
Yeah.
So, ma'am, okay, the chlorine has formed.
The chlorine is formed,
The
yes.
2 chlorine is formed.
Yes,
Okay.
but it can't form spontaneously.
Announcement for English Day. Port, please note.
Okay, like, you see that C that you drew?
Yes,
Can you please draw in another color? Because I still remember last day you told us this
About
the
the
C.
yes.
The C.
We'd also like to remind all learners there is no more paper towel in the bathrooms. There are proper towels in there. Please do not use them to wipe your shoes. They are there to wipe your hands. Thank you.
That's so unhygienic.
The 2 chlorides are taking the path of the C. In the non-spontaneous reaction, you use electricity. Then the chloride is oxidized to chlorine and the copper 2 plus is reduced to copper. But it's a non-spontaneous reaction. It doesn't happen by itself. Because if you look at the reducing agents, it's too weak. It's the weaker reducing agent. It can't reduce the stronger reducing agents, copper 2 plus to
Good
copper.
afternoon. I just want to do a quick announcement.
Because it's lost.
Okay? Are you with me now? You're going to go over it and familiarize yourself. Can I do another example? Okay? Let's put copper to No, sorry. Let's put copper chloride to aluminium.
Yes.
I want to know whether the reaction is spontaneous or not. Okay. So it's a copper chloride solution, and we put it to solid aluminium. Is the reaction spontaneous or not? Give me a chance to explain how to do it, because you can always go and watch the piece of video again. Okay. So in here we have copper 2 plus, and we have chloride ions, and we're going to have aluminium. Let's use the table of reduction potentials to see what is what here. This is an oxidizing agent. This is a reducing agent. And aluminium, we haven't seen it today. Where is it? It's also a reducing agent. Now, we've got one oxidizing agent, so I know that one is the one that's going to change. This one will change. Which one is the stronger reducing agent? This is the stronger reducing agent. So chlorine is not going to be part of this reaction. Chloride ions will be a spectator ion. So what will happen is spontaneously the copper 2 plus will gain 2 electrons, and it will make copper. And the aluminium will lose 3 electrons to make aluminium 3 plus, and 3 electrons will be reduced. It's another way to look at it. The stronger reducing agent is the one that will make the reaction take place. And yes, it is a spontaneous reaction, because aluminium is above copper in that table of reduction potentials. Are you with me?
Yes.
So aluminium is a stronger reducing agent than copper. Therefore, Al will reduce Cu2 plus to Cu spontaneously. Right, thank you.